Finding money, but and I agree that Yes, I decided to give you your homework assignment as notes because um, these problems take a while, and I didn't want to take up your time and then ask you to do 8 more of them. So I figured we could do a few together to just chip away. So make sure your, Chromebook is closed for goodness sake. And yeah, good job on your quizzes. Generally, they were pretty good. So what we're doing here is, by the way, the word regression, I should probably say what this means. There's all sorts of regression, and eventually we're going to use some technology to help us with this. We're going to take this for a spin today and see how long these take to do by hand. I don't remember. Could be 5 minutes, could be 18 per problem. I don't know. But anyways, regression is, and there's linear regression, quadratic regression, cubic regression, any sort of degree of polynomial, you can do what's called a regression. And a regression is where you take points and fit a curve to the points. If it's a straight line, if it's linear regression, that's obviously going to be easier. That's something we can generally just muscle through. But if it's a quadratic regression, just to give you some sort of perspective, like if I had 3 points that were like here, here, and here, then I would say, okay, I need to fit a quadratic through these. And the idea is we don't know exactly what it looks like, but we would guess that it goes maybe something like this. So our goal is to write the equation of the quadratic function, the parabola equation, that slices through all 3 points. And there's, like I said, there's technology can help us a lot. I don't want to have that be our introductory go. I want you to witness the process of how to do it by hand. And then, like I said, I might cave eventually in this lesson maybe, or even sometime later today and say, like, here are some tools you can use to save time on part of it. So let's get to it. So I'm going to give you the 3 points. We're not going to worry about looking at them graphically. So the first one, you have negative 1, 12 is a point that the graph goes through. 2, 3 is another point that the graph goes through. And then the last one is 4, 7. And the idea here is, again, if I wanted to put them on a piece of graph paper, I could, and it would at least give me like a ballpark as to what I'm working with, but that's really not something I'm interested in right now. So if you graph those 3 points, or if you don't, there's a curve that perfectly hits all 3 points. Our job is to figure out the equation of the curve. This has lots and lots of applications, so we want to get good at this. And like I said, today we want to do a little bit by hand and then probably eventually turn it over to computer programs that do a lot of the heavy lifting for us. So let's get to it. The main, like, big, huge crux of this is that when you start each problem, you want to write down this equation. And it's not like you've never seen this before. This is just the general form of a quadratic in standard form. And what we're going to do is we're going to hit that equation 3 different times. Every time we have a point, we're going to input his numbers in place of x and y. So like, for example, on this first one, the -1 is going to go in and replace the x's, and the 12 is going to go in and replace the y. But you have to repeat this process 3 times in order to create a system of equations. Okay, so let's take a look at what it looks like. So for this purple equation up here, we're just going to keep hitting it with numbers, okay? So if I change the y into the y coordinate at this point, what would it say first? 12. 12, like this y right here literally becomes this y coordinate right here. So it just says 12, and then it says equals. Now, in the next part, we're going to replace the x's. This equation over here has 2 x's. There's one here, and there's one here. So both of those x's are going to get swapped out with -1. So in the little yellow jelly bean right here, if you take the -1 input and square it, what do you get? You get 1. So instead of putting 1, I'm just going to put a, because that's what you would get if you did a times -1 squared. A times 1 is just a. Good. And then we're going to go to the second yellow arrow where there's another x, and we're going to replace it with -1. And that's right over here where I'm moving my pen. If you replace this x with -1, what would this whole term become? Minus b. Perfect. And then the last part doesn't have an input. It doesn't have any variability to it. So it's just going to always be plus c. So we have one equation. You might know where this is headed, but you might not, but you'll know soon enough. So that's step 1. And we're going to repeat that process now 2 more times. So this point is used up. It has served its purpose. And now we're going to go to the second point and do the same thing again. Replace the y first, and then replace both x's second and see what the equation says. So what's the y equals part going to say? 3 equals, good. And then again, you just have to be patient with this. The yellow jelly bean is the x squared part. So if you put the x, that's 2, and square it, what do you get? So this term is 4a. What's the second term going to be? So plus 2b. That's just replacing the x over there on the right with the x coordinate of the point 2. And then again, it's always going to be plus c. And you'll appreciate that here in a moment. You'll see why. If you don't know where this is headed yet, you'll know why having a column of c's is a good thing. What are we making? You got it. Our favorite thing in the world, a 3x3 system that we can use elimination on. Perfection. So that's why I say we might eventually turn some of the lifting over to technology so that we don't spend all of our time solving triple systems. But let's see how it goes. I don't think it'll take too long. And then we're going to do it again. I'm going to cross this point off because, again, he has served his usefulness, and we're on to the third one. What's the equation going to start as? 7 equals, that's the y equals part. And then the next one is x squared times a. What's x squared? 16. So our first term is going to be 16a. Good. What's our second term going to be? Plus 4b. And of course, plus c. The only thing about this that you might not recognize, especially if you're not particularly fluent or confident with mathematics, is that just the constants, the equals numbers are on the wrong side. I shouldn't say wrong. They're on a new side that we're not used to. So if you don't like it, if you want it to look more like what you're used to, you can take the equals 12 and put it over here, the equals 3 and put it over here, and the equals 7 and put it over here. And then having survived this class, you would recognize right away that we've got ourselves a 3x3 system. And I don't think that any of us walked away from our 3x3 unit and said, I really like that row reduction. It's not something that most normal humans feel like, I want to do more of that. So we're going to stick with elimination. And that'll be my stance. You're welcome to use row reduction if that's your thing. I'm just not going to do this problem both ways. Any questions so far as the construction of the system is concerned? These are all true equations. Every one of them is factual because they go into the general form of a quadratic and they use the inputs of a point that we know the quadratic passes through. So these are all factual statements. So if we can find the values of A, B, and C that make this system true, then we have found our equation. I mean, think about like where we're headed with this. I mean, let me underline some stuff for you. You would agree that if we knew A up there in the corner, and we knew B, and we knew C, then we could write the equation. So like, for example, if A comes out to 2, then we know the equation says 2x squared. And if B comes out to -3, then we know it's minus 3x. And if C comes out to 7, then we know it's plus 7. So then boom, we just did it. We wrote an equation. We have to go through now and solve for A, B, and C. That's the manual labor part of this. So let's get to it. This is, of course, just a hypothetical. So I think that we would be crazy to not take advantage of this column right here. You would agree, I think. Yeah, so we could just if you want to, we could take the top row right here and we could just multiply it by -1. And what that'll do is it'll create one of the C's as a negative, and then you can use that in tandem with the other rows to wash away the C's. And I don't feel like you need to rewrite the whole thing, so pay attention to my green pen here for a second. I'm going to just add a negative to this A. I'm going to change the B to a plus. I'm going to change the C to a minus, and I'm going to change the 12 to a -12. That really is perfectly legal in a case like this. There's no harm, no foul. And that just saves us like 30, 45 seconds of having to copy the whole system over. Everyone okay with that? Okay, now it's time to do some row operations. It's been a hot minute since we've done this. So what's our first row operation going to be? Good. So we're going to do R1 plus R2. Draw a little arrow, and we're going to get an equation. What's that equation going to say? Mm-mm.
5B.
Nope.
Oh, wait, I thought I was on wrong. 3B.
3A. So perhaps you guys need a little guidance. Follow the purple box here. First off, do we all agree that we're adding row 1 to row 2? Look at the purple box. These terms come first. And I'm going to erase this box in a second, but we all agree that that's the first thing that has to happen. You add your A's, you add your B's, you add your C's, you add your B's. I don't care. No, I just did it so that no one would get mad at me. I don't care if you leave them on the other side. Got it. So I just did this for comfort. There's always those people that are more comfortable if things just look the same way they've always looked before. So any questions other than that? Okay, now let's add row 1 to row 2. How many A's do we get? 3. -1 plus 4 is 3. Cool. How many B's do we get? 3. 1B plus 2 B's right here where I'm moving my pen is 3 B's. How many C's do we get? Of course, that's the whole point, right? And what is -12 plus 3? -9. Good. What's the next row operation that we're going to do? Row 1 has to be involved plus row 3. We made that top one a negative so that he could play in all of our row eliminations. He's our guy. All right, so focus now. If we're going to add the top row to the bottom row, start with the A's. How many A's do you get? 15. Because that's -1 plus 16. How many B's? 5. And what's -12 plus 7 all the way over to the right? -12 plus 7 is -5. There is a nice way to do this. Do you see it? For sure. Yeah, good. You've been hanging out with me for a while. If that's your first thought, good job. -5 times the top row is a winner. That's going to turn our A's into opposites, eliminators. So down here below this bottom equation, I'm just going to write the result of that. Bless you. What would my first term be? Okay. So these two equations with the red bracket around them are the two that we're going to add together. We're using the original bottom one with the newly created top one. And then, of course, I mean, if you're feeling like that you're doing this for the first time, then you forgot how to solve triple systems way too fast. How many A's do we get? So we're adding these two equations in the box. Everyone okay? Right, no A's, they cancel. Boop, gone. How many B's do we get? -10 of those B's. And what is -5 plus 45? What's B?
-4.
Okay, this is great news. Okay, that's a very important piece of information. That's going to be 1/3 of the answer. Now, who do we have to find next? You have to find A. You cannot find C because you don't have any equations that have C and one other variable. All of your C's, you'd need to know A and B both to do C. That's why we find A next. And I hope you're in agreement with me that this one in the purple egg is far and away going to be the most peaceful. So I'm going to use that equation and I'm going to change his B into -4. And it's going to say 3A. What's this going to be right here? -12, right? Because the B is not there anymore. The B became -4 and +3 times -4 is minus or -12, whatever you want to call it. Equals -9, add 12 to both sides, and 3A equals, what's -9 plus 12? What's 3 divided by 3? So we now know 2/3 of the answer, leaving us now with the need to find C. And you may use any equation involving A's, B's, and C's, any of your originals, any of your modified. The original top one, is that like before we added the negatives to it? No problem, sure. So the top equation, in case you've forgotten, before I mooked around with the signs, the top equation, I'm going to write it again for you. It used to say +A minus B plus C equals 12. Okay, you don't have to use that. You can use the one with the negative through it. Doesn't matter, because I've always said any of them will work just fine. So what are we going to change the A into? A is 1, so we have 1 plus 4, because that's -4 plus C equals 12. And then from here, 1 plus 4 is 5. And if 5 plus C equals 12, then what is C? C is 7. Now, these three things in the yellow eggs are your answers. However, they're not the answers, really. They're the tools or the pieces that you need to actually write your answer. So knowing those three pieces of information.
Please excuse the students going to the LCCC brand brass band concert now. Thank you.
So remember that you don't have to write what I'm writing. I'm just doing this again. My goal is always to confuse as few people as possible. So this is what the equation generally says. Now we're just going to change A, B, and C into who we know they have to be. So what will our actual answer say? Y equals
X squared.
X squared. B is -4, so we're just going to put -4x, and that is the equation. And it's fun to think that if you graphed that parabola, it would perfectly slice right through all three of the points that we started with. Not too bad, right? What'd you say, Kane?
For real?
For real. Would you like to see?
Thanks. Thanks.
Hey, Mari, I'm trembling.
So we did x squared minus 4x plus 7, I believe was our answer. And the 3 points that we started with were -1, 12. And you can see right here that this is the point -1, 12. The graph goes right through it. Another point, Kane, are you paying attention?
Yeah.
Another point that we know it goes through is 2, 3. And I can zoom in on 2, 3. It's right here. Do you see it? And then another point that the graph goes through is 4, 7. And you can see that one right here. Got it? So it's pretty cool stuff that we just wrote the equation of a quadratic, forcing it to go through 3 exact points. That's called regression. All right, let's go again. Round 2. So you have the problem in front of you, so I don't feel the need to write the points down. This is the equation that every time I start a problem, I'm going to write this down. Maybe you write it once at the top of your paper. That's up to you, but I feel like having it handy is huge. So knowing what you know now, what would the first equation say for problem 2? 10 equals 4x,
Oh, we- okay.
4a, apologies, minus 2b or not 2b plus c. Good. 1 down, 2 to go. Okay, so you could cross that point off just so you don't accidentally look at it. Don't vandalize it to the extent that you can't read it. Just maybe give it a little strike through so your eyes don't wander. What would the second equation say? Equals a plus b plus c. You've got to remember that once you use the y, the -2, you don't use it again. You just put x where these little yellow circles are, okay? So you do the x twice, but the y you only have to do once. What's the third equation going to say? 0 equals 9a 3b plus c. So this time I won't move the 10, the -2, and the 0 to the other side. That seemed to cause a little bit of confusion. So just leave it like it is. Doesn't matter. Or construct them with it on the other side. Who cares? At the end of the day, like that's the kind of thing in math that just doesn't matter. So same thing again. Let's take the top row. It seems to be pretty convenient. Let's multiply it by a negative. So again, follow the green pen here. I'm going to add a negative onto the 10. I'm going to add a negative onto the 4y. I'm going to change the 2b to a plus, and I'm going to change the c to a minus. And we're doing that to create that infectious negative c that we can then subsequently use to murder off the other c's. One of them has to be negative, or at least different than the other two. And it's pretty repetitive. So what is row 1 plus row 2? Let's see if this goes a little better this time. Go ahead. Say it again.
We're going to.
Start here.
Yeah,
-12
equals.
equals -3a. And then there, of course, is no c because we killed it. All right, let's do the next row operation. If you want to change these up, you could do them differently, but really it's going to just work this way every time if you want it to. Might as well keep it the same. What's row 1 plus row 3? You are adding, yeah, you're adding the rows with the big red dots next to them now. Okay, so have focus. -10 equals, good job.
Plus 5b.
Nice. Perfect. So again, we find ourselves in a 2x2 situation. We don't have a quick road like we did last time. Which A or B should theoretically be quote unquote easier to eliminate? A should be easier. Why? Because it already has a negative positive dynamic. I mean, all things being equal, you're going to have to multiply both equations anyways. You might as well do the option where you don't have to use any negatives. We love the A's, how there's a staggered negative positive dynamic. What do we multiply the top by? Bottom. Let's do it. And so this time we are just going to reconstruct the whole system. All right. So no shortcuts here. Like you don't want to write one above and one below. It's really easy to get confused if you do that. So my new bottom equation is -60 equals -15a plus 15b. The bottom. And those b's tried to cancel, but they're not going to. So when we add these two equations together, the a's eliminate, and then what are we left with? -90 equals 30b, what's b?
Mm-hmm.
-3. And I will put a yellow around that. And one down, 2 to go. Which equation is probably the most attractive? Top's fine. Yeah, honestly, they're 6 of one, half dozen the other. These are both about the same. So let's just do the top. And so we're going to rewrite the equation over here. I'll just follow the big white arrow there. It's going to say -12 equals -3a minus 9. That's just changing b into -3 since we know what it is. Add 9 to both sides. What do you get? You get -3 equals -3a, and then a equals +1. And this is where we storm the castle. You now have enough levels to go solve for C, and I would imagine that you'd probably be sent for a drug test if you didn't pick that one. Some sort of screening, perhaps. So that's the best equation that I can possibly see that we could use here. So it's going to say -2 equals 1 minus 3 plus C. And then you do the math. -2 equals, what's 1 minus 3? -2. Add 2, you get 0. So this is an interesting, but really not that interesting scenario in that when we write our final answer, there's just not going to be a number in the back, unless you're one of those people that likes to put zeros. You do you. Not wrong. So our final answer is y equals 1x squared. So I just put x squared minus 3x, like that. So again, if you want to put +0, it's not wrong at all, but you certainly don't need to. And then you will also see, I don't remember where I put it in here because these are all jumbled up now. Like when I wrote them, they just found new homes. You will also get at least one on here where your b is a 0. Hugo, I'll answer your question in just 1 second. So let's say we finish one and we get like a equals -4, b equals 0, and c equals 5. Just making this up. What would the quadratic equation say that we would write? Like that. So if you get a 0 as one of your 3 numbers, and you won't ever get 0 as the first number, a, because then it wouldn't be a quadratic, right? So it's either going to be b or c, and if one of them's a 0, it just takes a term out, essentially, right? Hugo, what was your question?
I don't know if I'm onto something, but is it right that the last one of these has to do something with the thing that we get?
The last point?
Yeah.
It might in these cases have something to do with it. I think maybe the way I'm constructing them, maybe the way I wrote them,
Yeah.
but why don't you test that theory as you go through the assignment?
Okay. Yeah.
And if it keeps happening, then maybe full disclosure, when I wrote these problems, because you're not interested, but I'm going to tell you anyways. As I was sitting there watching basketball yesterday, what I did to write the problems was I just wrote a random quadratic. So like I wrote like y equals -3x squared plus 5x minus 2. And then I let the calculator find table values for me. And I picked 3 random ones. But when I picked them, I didn't want to pick one that was like -6, 124, because I knew you'd have to work with them. So the numbers that you're seeing are kind of closer to 0. So there might be some connection to what Hugo is saying in a case like this. But if you don't know what he's talking about, then don't worry about it. It'll come to you if it's meant to. So do you have any questions for me? All right, let's give it a shot. I don't think these take very long. I mean, honestly, 5-6 minutes a problem, I don't think is unrealistic. So let's stick to by hand for a while, and then maybe tomorrow I'll start showing you how to use technology.